And if I select this and press Ctrl Enter, they provide this plot. Okay. Alright, so this is like the preliminary task, and now let's use the data set that we have downloaded, and this is our next example, our book example. In the previous lecture we have already started this example, but let's remind. So we illustrate this with 140 claim sizes, settled amounts paid after excess in dollars. They arise from claims on a general insurance portfolio, and they have ranged from 8 to 34,975. So what we are going to use, we're going to insert R and use the libraries read Excel. read Excel hasn't installed, so let's install this package. Install. Okay, and also let's install the Tidyverse package. Okay, and the final one, psych. Alright, yeah, it's very complex. Takes a couple of minutes to install. Why psych doesn't package libpath version? Okay, let's execute again. Install. Yeah. Alright, so now we are going to use these packages also. We click library, read Excel, Tidyverse, and the final one, psych. And let's read the data from our data set. So we click import data from read Excel and click this book 1. And first row is names. No, I guess that's it. So the command we have used is like this: book 1, read Excel, call names false. So now book 1 appeared to be our data set with 18 observations and 8 variables, and we are going to change it to matrix and then vector. So the same as previous, as matrix. I just reshape this data set, and book 1 is as vector. Alright, so now book 1 contains 144 variables, 144 observations, I'm sorry. And then we delete omitted values from it. is happening? Okay. And I emit book 1. So after executing this command, we read our data. This is the data read. Then we reshape. Now it's vector. Now it is vector. And delete empty values. Okay, so in the end our book 1 is the vector of 140 observations. Let's put the summary of it. And we see this, the minimum of 8 and the maximum of 34,975. And we see that the mean and the median moved to the left side. So mean should be almost 16,000, but it is much less, and half of observation are less than 1,131. So that's quite large claims inside appear to be, but they are rare. So the third quantile and the maximum values are very different. So there are few large values. And in the previous lecture I have showed you how to plot histograms of this book 1. And we insert breaks equal 30. Okay, so this is the histogram of our book 1. Like this, few large claims appear to be here with low frequencies, and most of our claims are below this small value, below 2,939. Alright, what are we going to check further? So we are going to check this standard deviation of our book 1. It is appeared to be very large, so the variance is the squared, and it is way much higher than the mean. So we have the fat tail. Also we are going to check the skewness of book 1 and the kurtosis of book 1. The skewness and kurtosis. And that's why we loaded the package psych. This is the skew and kurtosis, the functions from this psych package. Okay, we see that there is a high positive skewness of the sample, and it reflects the fact that the standard deviation is large compared to the mean. And this suggests in turn that the exponential distribution may not fit the data well. Okay, we note also that the very high value of this kurtosis coefficient, 16, very high value. So now we are recapturing what we have ended with our previous lecture. So this is now a recap. We have created in the previous lecture the WH values, and used the which book 1 are more than 10,000, and we have let's say we calculate the LC1 and LC2 variables. LC1 will be the length of this WH over the length of book 1. So what does LC1 shows us? WH contains the indexes of values which are more than 10,000 in their magnitude. So these are 18, number 18, value 36 is in magnitude more than 10,000. So this length of WH is this number 9, okay? And we divide 9 by the length of book 1, and length of book 1 is 140, okay? So we just divided 9 by 940, and we got something. Alright, we got LC1. Let me check, hold on. Do I have the same? Yes, I have the same. So this is the proportion, 6.4%. So this is our LC1. 6.4% of values are larger than 10,000. And let's create LC2 and change for LC2 to 20,000. And LC2 will show us the proportion that 2.1% of values are larger than 20,000. So these are two parameters, LC1 and LC2, we are going to check further on in order to understand how good our distribution fits the large values. Okay.